All right, I'm just gonna walk through some of the density notes here. So density equals m for mass divided by volume. M over V, that's the formula. Over here, if you're looking at this tower, this is what we call a density tower. And you can see that the most dense items are gonna sink to the bottom, while the least dense items kind of float to the top. So oil is less dense than water, and that's why oil floats on water. Density describes the relationship between the mass and volume of a substance. So density is going to compare mass and volume. The most common units are going to be grams per milliliter or grams per centimeter cubed. The density of water is simply 1 grams per milliliter or 1 grams per centimeter cubed. It is useful to know this because we can compare the density of water to other things. So one thing we can ask ourselves is, will it sink or float in water? Excuse me. Density is a physical property. It's also an intensive property. It doesn't change when you change the size of a substance. So if you had a piece of cork, for example, it'll float on water. Even if you had a giant piece of cork, it's going to float on water. Okay, so it doesn't matter what size it is, it'll have the same property. Same with like a piece of wood. Okay, you're going to do a little mini lab next. So if you want to switch the video to do the mini lab, make sure you record all the data and fill in that table calculating the density. It's simply mass divided by the volume. Hey everyone, today we're going to do the density mini lab. We're going to do a little POV style here. So first we'll take the mass of all the different items, and I'll start with the ethanol here. So I'm going to take my graduated cylinder, and I don't want the mass of the graduated cylinder, so I'm going to hit this tare button. That'll turn it to 0. And I'm going to take the ethanol, and I'm just going to add a mass to that. Okay, go ahead and record this number, 5.24 grams for ethanol. Okay, next, let's go ahead and do water. So I'm going to take another graduated cylinder. Again, we don't want this number, so we're going to hit the tare button. I'm going to take my H2O. And let's take the mass of this H2O. Okay, we'll use this number, 2.87 grams for the 2.88 grams for the water. Either number is fine. Notice for the electronic scale here, we don't have to add an extra digit. The electronic scale is pretty exact. It's only changing because there's air conditioning on right now. But you can use either number, 2.87 or 2.88, and we're not adding any extra figure to that. Okay, so let's keep it going with our third item. So over here we have a rubber stopper. You can see it's kind of a funky looking item. This is used on test tubes and sorts. And we're going to take the mass of this rubber stopper, so I'm going to hit 0. And the mass of the rubber stopper, 5.10 grams. And then our last item, we have a die, right? Singular is considered a die, not dice. So we're going to take the mass of the die here. And that'll be about 5.8 or 5.79 grams. That's the mass of the die. All right, next I need to record the volume. So before we can calculate density, we need both the mass and the volume. The volume of the ethanol, I'm gonna look closely here, is gonna be 6.6 milliliters. So that's the volume of the ethanol. The volume of the water, if I look closely, let's take a look. Let's see. So I'm trying to be flat. 2.2, 2.4, 2.6. So that's going to be 2.8 milliliters for the volume of the water, 2.8 milliliters. And then the volume of the rubber stopper here. So notice this is a really weird shape. It's going to be kind of hard to get the volume of this. So we have to use a different method. And so we're going to do what is called volume displacement. And so how that works is I'm going to take this rubber stopper and I'm going to see what the volume is now. So first, my starting or initial volume is 53 milliliters. Okay, that's your initial volume. And then I'm going to put this in there and see how much the volume changes. So we can see how much the volume changes, and if we see the difference there is going to be the volume of the rubber stopper. So at first it's 53 milliliters, and then afterwards, let's see. Oops. So it looks to be about 58 milliliters. Okay, so you want to take the difference there, 58 minus 53, to get the volume of this rubber stopper. Lastly, we have a die. And so this cube object, instead of doing volume displacement, perhaps in math you learned how to take the volume of objects. And so here we can just do length cubed, because it is a cube. And so I'm going to measure the length in centimeters here. So in centimeters, I'm gonna say that's 15. So that's 1.5 centimeters. Okay, you can see it here, about 1.5 centimeters on each side. So you would just cube that number. And there you have it, that's the volume. Make sure you fill out your data table and calculate the density. I'm going to continue on and work on some practice problems here. I won't solve all of them, but I'll get them started for you. So what is the density of a substance whose mass is 15 grams and volume is 30 milliliters? So I always like to write what's given. They give me M and they give me V. Okay, so here I just have to combine those numbers. Density is going to be 15 grams over 30 milliliters. You can punch that in. Make sure your final answer has the correct number of sig figs as well. Our second example problem here. The density of a substance is 0.5 grams per milliliters. So they give us density. And it occupies 2.3 milliliters. So milliliters is always going to be volume. What is the mass? So I don't know the mass here. So I'm going to help you out. If we do some algebra, we can rearrange this equation. And mass is going to equal density times the volume. So all you got to do is plug in these numbers and solve for the mass. Okay, last example problem here. The density of a substance is 1.5. So they give us the density, and then give us the mass. The mass is 23.8. What volume does this substance occupy? So same thing here. If I do some algebra, I can basically switch these two around. I'm multiplying both sides by volume, and then I'm dividing both sides by density. So algebraically, we can end up with a volume formula. It's going to be mass divided by density. So you've got those two numbers. Go ahead and solve, and for all these, make sure you're using the correct units and the correct number of significant figures. Okay, that's it.